In this video, we're going to cover network documentation and diagrams. Documentation might not seem like the most exciting security topic, but it is foundational. A network you haven't documented is a network you don't fully understand. And a network you don't fully understand is one that you can't fully protect. Good documentation is also a regulatory expectation. Most OT security standards like ISA IEC 62443 or NERC CIP and others specifically require current, accurate network documentation. Auditors look for it. Incident responders depend on it. And anyone new to your environment, including you, when you come back to this network after 6 months focus on another project, depends on it to understand what's there and why. There are three distinct types of network documentation, and all three are needed for a complete picture. Many OT environments have one or two of them, but not all three. Physical topology documentation shows what's connected to what physically, which devices connect to which switch ports, which switches connect to which routers, where cables run, and which patch panel ports correspond to which devices in the field. Physical topology tells you the hardware reality of the network. Logical topology documentation shows the network as the software sees it, which VLAN each port is assigned to, which IP addresses are assigned to which devices, where subnet boundaries are, where firewall rules enforce zone boundaries. Logical topology tells you the security architecture, the zones, and the controls between them. Data flow documentation shows what communicates with what, over what protocol and why. Which SCADA server pulls which VLCs, on what port and at what frequency. Which historian server collects data from which sources. Which vendor systems connect remotely into what. Data flow documentation tells you whether the network actually operates in the way the logical topology intends. A discrepancy between data flow documentation and logical topology is a security finding. If the data flow shows a path that shouldn't be permitted by the logical topology, something is wrong with either the documentation or the firewall rules. Network diagrams use a standard set of visual symbols that are consistent across vendors and tools. Routers appear as circles or cylinders, often with arrows or lines indicating routing interfaces. Switches appear as rectangular devices with port lines across the edge. Firewalls are often shown as a brick wall symbol or a shield icon positioned between two network zones. Servers appear as rectangular boxes, sometimes drawn in groups or stacked to indicate clustered or redundant configurations. Cloud shapes represent untrusted external networks, the internet, or a carrier network. VLAN and zone boundaries are shown as dashed lines or colored boxes drawn around a group of devices. The color or line style indicates which zone a group of devices belongs to. A firewall icon positioned in the line between two zones indicates where access control is enforced. Learning to read these symbols quickly lets you extract the security architecture from any diagram without needing someone to explain it. Look for how many zones are shown, where the firewalls are positioned, and whether any device appears to straddle two zones. When you receive a network diagram from a vendor, from an auditor, from a colleague updating you on a network change, there are specific things to look for from a security standpoint. First, look at the zone boundaries. Are there clearly defined zones? If the diagram shows all devices on a single flat network with no zone markings, there's the flat network problem. How about firewall placement? Is there a firewall between every zone boundary? A diagram that shows OT and IT zones but no firewall between them indicates either a missing control or a documentation gap. Devices spanning zones. Look for any server, workstation, or appliance that has connections to more than one zone. A historian server with lines going to both the OT zone and IT zone without passing through a DMZ is the dual homed historian bridging risk we talked about earlier. Any connection that runs between non-adjacent Purdue model levels, for example, a direct connection from level 4 enterprise to level 1 control without passing through the DMZ and appropriate firewalls, is another design concern you would need to pay attention to. Documentation needs to reflect the current state of the network, not the state it was in at the last commissioning. OT networks change, equipment gets added, replaced, and decommissioned. Network segments get restructured. Vendors change how they connect. Temporary connections get made during outages and stay permanently. Each of these changes should trigger a documentation update. The practical recommendation is to identify who owns the network documentation. Make updating it part of the change control process for any network modification, and set a schedule for verifying that the documentation still matches the actual network. The verification process, plugging a laptop in and comparing what show ARP and show IP interface brief report against what the diagram says should be there. These are commands you could issue on different devices, switches, and systems. This can catch the drift between documentation and reality. One important note on where to store documentation. Network diagrams and connection matrices should be stored somewhere accessible when the OT network itself is unavailable. If your documentation lives on a server inside the OT network and that network is compromised or unavailable during an incident, responders can't access the documentation when they need it most. So store it off network in a secure location with backup access. In the next video, we'll cover backhaul communications and how remote SCADA sites connect across geographic distance and what the choice of communication medium means for security and reliability.